Hello everyone. Welcome back to Digital Lessons for Students by Department of School Education, Nagaland. I am T. Pungudi from CD King Higher Secondary School, Science Stream, Jatsama, Kohima. In the last 3 sessions, we learned matrices, what are the types of matrices and operations of matrices and transpose of a matrix, symmetric and skew symmetric matrices. Today, in this session, we are going to learn elementary operation or transformation of a matrix. See, there are 6 elementary operation or transformation of a matrix. 3 due to rows and 3 due to columns. So in total we have 6 transformations. The first one is interchanging any 2 rows or columns. So we can do this operation in a matrix. Either we can interchange any 2 rows or we can do with columns. See, let's see an example. For example, A is 1, 2, minus 1, 5, 0, 6. Suppose if we wish to interchange this second row and third row, that is R2 is getting interchanged with R3. So we denote this symbol R2 interchanging with R3. So the result matrix will be equal to 1, 2, 0, 6. This third row will go to the second row and the second row will come to the third row. That is minus 1, 5. This is the first operation. If we like to interchange, here there are only 2 columns. So if we like to interchange these 2 columns, we write like this: C1 getting interchanged with C2. So that is 2, 5, 6, 1, minus 1, 0. Yeah, this is the first operation. This is due to row and this is due to column. Okay. The second one, multiplying elements of a row or a column by a non-zero number. Multiplying elements of a row or a column by a non-zero number. Suppose if I wish to multiply this R2, that is row 2, with 2, then we write in this way: R2 as 2 times R2. So it will be, the first and third will not take any change, only the second row we are going to multiply with 2. 1, 2, minus 2, say 2 times R2, so minus 2, 10, 0, 6. This is how this operation works. In case of column, suppose I wish to multiply C1 with minus 1, that is minus of C1, then what will happen? A will become minus 1, plus 1, 0, and 2, 5, 6. Okay. The first one is interchanging any 2 rows or columns. The second one is multiplying all the elements of a row or column with a non-zero scalar. The third one is multiplying each element of a row or a column by a non-zero scalar k and adding them to the corresponding elements of another row or column. See, if we wish to multiply a particular row by k with all the elements and adding this value to another corresponding elements of the another row, then that will goes to this row. Ri takes Ri plus k Rj. We can do with this column also. See, we have multiplied Cj with k and adding them with the corresponding elements of Ci. So which place it will take? It goes to Ci. Let's see an example. A is 1, 2, 0, minus 1, 3, 5, 2, 4, 6. Okay. According to this, first let me do with the row R2. We'll do with R2. R2 plus 2 times R3. So you do remember which one you want to get transformed. That row should be written in the beginning. Then only the other one should be written. This should not be written as R2 takes 2R3 plus R2. It's wrong. We should not write like this. So which row gets transformed? That should come in the beginning of the operation and then the other one. This we have to be careful. So here we like to multiply these elements of row 3 with 2 and adding them with the corresponding elements of R2. So R1 and R3 will not be transformed. It will remain the same. 1, 2, 0, 2, 4, 6. First we can write this. Then R2 only it's going to be transformed. See, 2 here. R2 is what? Minus 1. This is the operation. Minus 1 plus 2 times of or twice of the corresponding element of minus 1 is 2. So what we get? This minus 1 plus 4, that is plus 3. So this will go to here. Right? The next one, 3 and 4. R2 and R3 only we are involving in this operation. So 3 will be written as 3 plus twice of the corresponding element, 4. So this will give you 8 plus 3, 11. So that will go here. The next one, 5, takes 5 plus twice of 6. That is 17. This is how it works. This is by the row wise. If we want to do it along the column, we can do it. Let's see. Suppose C1 as C1 plus C2. So I am going to add this C1 and C2 and putting in the place of C1. Let's see. C2 and C3 will not change. So let us write that one first. 2, 3, 4, 0, 5, 6 in order to avoid confusion. Then we will add this C1 and C2 and put it in C1. So add this 1 plus 2, 3. So that goes here. Minus 1 plus 3 plus 2. That goes here. 2 plus 4, 6. Done. This is how this operation works. This is by the row wise and this is by the column. So this is the third elementary operation. So the first one is interchanging any two rows or columns will be written as Ri getting interchanged with Rj and Ci getting interchanged with Cj. And the second one is multiplying any elements of a row or a column by a non-zero scalar. It will be written as Ri takes Kri and Ci takes Kci. Then the third one is multiplying each element of a row or a column by a non-zero scalar and adding them to the corresponding elements of another row or column. That is, Ri takes Ri plus Krj, Ci takes Ci plus Kcj. So if you are clear with these 3 plus 3, 6 transformations, we can easily find the inverse of a matrix. Before we move on to that topic, let us learn what is this inverse of a matrix. Inverse of a matrix. Let A be a square matrix of order M. Then there exists a matrix B of the same order. That is very important. Same order such that AB is equal to BA is equal to I. AB is equal to BA equal to I. Let A be a square matrix of order M. Then there is a matrix B of the same order. Then if we do the multiplication AB or BA, we get the identity matrix. Then in that case, this B is called the inverse of A. Inverse of A. If a square matrix have inverse, so here A has inverse, what is it? B. Then A is said to be, B is inverse of A and A is said to be invertible. invertible. See, if it satisfies this condition, AB equal to BA equal to I, then B is the inverse of A and A is said to be invertible. Of course, A is also an inverse of B. A is also an inverse of B. Inverse of B. A is inverse of B and B is inverse of A. A is also an inverse of B and A is said to be invertible. You have to be very clear with these words: inverse, invertible, and this condition. If you say that a matrix has inverse, then it must satisfy this condition. Then only we say that it has inverse and it is invertible. Okay. Does it exist for rectangular matrix? No, clearly not. It exists, the inverse will exist only for the square matrices, not for rectangular matrices. Yeah. An important result, the inverse is always unique. You cannot find two inverses for a single matrix. A inverse is, and we denote the inverse as A power minus 1. You should not read it as A power minus 1, just for your understanding I am saying this. A inverse, this you should call it as A inverse. A inverse is always unique if it exists. If it exists. Sometimes it may not have. It doesn't mean that every square matrix will have inverse. No, it's not possible. It's not like that. Some matrices may not have inverse if it is not satisfying this result. A inverse is unique if it exists. And the other one is AB whole inverse is equal to B inverse A inverse. These two results you can easily learn from your textbook. The proof is very simple. You can go through. The first one is A inverse is unique if it exists. The second one is AB whole inverse equal to B inverse A inverse. Then we will move on to the important topic, which always an expected problem in the board exams. It would come for 4 mark or for 6 mark sometimes. Inverse of a matrix by elementary operations. There is another method to find the inverse of a matrix that we will learn in the next chapter, determinants. After we learn the determinants, we will know how to find the inverse of a matrix by another method. Now, inverse of a matrix by elementary operation. Listen carefully. Inverse of a matrix by elementary operations or transformations. Elementary operations. See, here elementary operations, we know row transformation and also column transformation. So, we can find the inverse of a matrix either by the elementary row transformation or by the elementary column transformation. If it is mentioned in the question paper, particularly solve or find the inverse of a matrix by elementary row transformation, you have to do the particular method. If not, it is up to you. You can choose a row or column which you find it easier. So, elementary row by row transformation and column transformation. How to get? There will be a square matrix A. We can write this matrix as I into A, right? Here in case we write A equal to A into I, right? This form you should know. When you are doing by row transformation, you have to write the given matrix as A equal to IA. If you are doing by column matrix, you have to write it as A equal to AI. If you change the order, then your answer may not be correct. Then we apply these transformations. In order to convert this, it will take few steps. Finally, you will change this into I matrix. In that way, you should operate this, apply these operations. When we apply this side, we will apply the same operations on the right side as well. In that case, this I matrix will be transformed into another new matrix, let it be B. This A, let us keep only A only. Let us not give the matrix values here. Only you put the matrix here and I matrix here. You just keep the capital alphabet A only till the last. It will remain as A. So what is this gives us? It's giving us BA equal to I. So that means when we get this method, what we call? B is an inverse of A. So we get the answer from here. B is the inverse of A. This is how we find the inverse of A. And here we apply all the row transformations, not the column transformations. That is important. Once you decided to use row transformation, till the last, in every step, we must use only the row transformation. We should not mix up row and column. Then we won't get the answer. So if you decided to use the row transformation, till the last step, you use row transformation, that is any of these three, till you get I here and it changes into your new matrix here. Similarly here, when we apply the column matrix, column transformations, this will be transformed into I. In such a way we have to apply this transformation. Then this A will remain A and this I will be transformed to a new matrix B. By definition of inverse of matrix, then B is the inverse of A. This is how we get the inverse of matrices. So I'm going to show you the row transformation. Then you try by yourself the column transformation. This is by row transformation. See, let me choose a question from your exercise. 1 minus 1, 2, 3. 1 minus 1, 2, 3. Let it be A. It's a 2 by 2 matrix. First I'll show you one 2 by 2 matrix, then we will move on to the 3 by 3 matrix. Okay. Since I'm going to use this row operation, let us write, we can write as A equal to I into A. Please don't change this order, A equal to IA. What is A? 1 minus 1, 2, 3. That is equal to I matrix. Since it is a 2 by 2 matrix, so we have to choose the identity matrix also of order 2. That is 1, 0, 0, 1 into A. Here you do not need to give the values of the matrix. Just keep A only till the last. See, as I already told you, we have to reduce this matrix into an identity matrix. And by that time, it will also transform into a new matrix. That is our answer. Okay, how should we change this? I'll tell you one simple trick. Identity matrix means this will be 1, this will be transformed to 0, 0, 1. First, we will change this element A1, 1 position. Here we want 1. Already we have 1, so we are lucky. If not, we have to convert this into 1. And then you move on to the same column, the next element, that is 2. You convert this 1 into 0. This is equal to 0. First you change this one, this number equal to 1, and you move on to this element and convert this, reduce this equal to 0. Then you move on to this element. This one we have to reduce it in equal to 1. Then we move on to this number. We will convert this to 0. If you go in this order, you will get the answer within 4 steps. If you change this order, you may be getting the answers, but it may take longer. So first we will convert this to 1, and then we move on to this element, then we change this into 0 using this element. That also important. While you convert this 0 to this to 0, you have to use this element and also using the transformation. And then move on to this element and convert this to 1, and move on to this element, this to 0 using this element and also with the help of elementary transformation. That is, you are going like this. Starting from here, you move on to here, and then this element. If you go by this pattern, you will get the answer easily. So let us do one by one. Now also one more thing, you can reduce this first element, whatever it is, you are converting 1, this also to 1 and this also to 1. You can divide the same the row by the same number, then it will easily change it into 1. Otherwise you can use other elementary operations also, even this also you can use it, it is up to you. Let us see, this is already 1, so no problem. Then I will move on to the next element, that is I am going to transform this to 0. How can we get 0 here? 2 is there, so 2 minus 2 will become 0. So how to get this? This belongs to R2. Let us use the elementary operation here, R2, this is 2 minus I need 2, right? Simply we cannot do this, so let us multiply this with here. To convert to 0, we have to use that number 1, then only it will become 0 easily. And also do remember which row you are converting, that should come in the beginning. If you write this one as 2R1 minus R2, this also will give you 0, but this is wrong. It should be always the first which you are transforming, that row or column should be written at first, then followed by the other one. Now see, here 1 minus 1, the first row will not change, and so let us first write that one to avoid confusion. And also what you are applying, the elementary operation or transformation, you are applying this operation here. This must be mentioned in your answer script. If not, you will be losing some marks. So this is important to write, and this is 2. So I am going to apply this here. 2 takes 2 minus 2 into what is R1? 1. So it becomes 0, so I put 0 here. Then the second element, not only for that element, we have to apply for all the elements in the row 2. So 3 takes 3 minus 2 into what is this corresponding element? Minus 1. So it will be 3 plus 2, that is 5. So it will become 5. Then here 0 takes 0 minus 2 into what is the corresponding element? 1. So that is minus 2. Then here 1 takes 1 minus 2 into 0. So that is 1. That's all. We have converted this into 0. The next our aim is to reduce this number equal to 1. So how can we do that? So let us divide this R2 by 5. So 5 by 5, 1. So let us do that. So in this case, R1 will not change, 1 minus 1. So here 1, 0 into A. Divide by 5, 0. Divide by 5, 1. This is minus 2 by 5 and this is 1 by 5. Okay. So only one more number. We have to convert this to 0. How will we get 0? Minus 1 plus 1 is 0. So we have to use this number 1, not this number, okay? You have to use this number. Then only R2 row operation works. So that is R1, this belongs to R1. So R1, first you write R1, then you think of it, what you should do to make it 0. So plus, to make 0, please remember you have to utilize the 1 present in the same column. So that is R2. Then this is 1, 0, 0, 1. Obviously, it comes like this. Then here we are adding these two. So 1 plus of minus 2 by 5. If you take the LCM, you get 3 by 5. Then 0 plus 1 by 5 is 1 by 5. R2 will not change. Minus 2 by 5, 1 by 5 into A. Right? Can we take the 5 outside as common? So this will be 1 by 5, or if you want to leave like this, it's okay, it's up to you. 3, 1, minus 2, 1 into A. So A is written as a matrix into A. Then this is the inverse of A. Some students, they skip to write the conclusion. They stop here. They don't write the last part. So that is A inverse equal to 1 by 5 into 3, 1 minus 2, 1. This must be written to conclude your answer properly. Yeah, hope you have understood. See, first let us write the given matrix as A equal to IA. You give the value of A and I. Then our aim is to convert this matrix to an identity matrix. When we do, this matrix also automatically will get transformed to a new matrix. Then finally, when we reach this one as identity matrix, that matrix will be our answer, that is the inverse of A. So first we will convert this to 1, and then the same column you move on to the next element, then change it into 0 using this 1, and then move on to the next column and change this one into 1 and move on to this element, convert it into 0 using this 1. If you go by this pattern, then it will work easily and you get the answer very easily. Then I will tell you how to solve a 3 by 3 matrix. 2 minus 3, 3, 2, 2, 3, 3 minus 2, 2. Here, first we have to start with here. Convert this element to 1 and then go here. This one to 0, this one to 0, right? Then you go here because identity matrix will be like this: 1 0 0 0 1 0 0 0 1, 3 by 3 matrix. So we convert this to 1, and then you can do this at the same time also, no problem. You can apply 1 or 2 operations at the same time. This will be 0 and this will be 0, and then go here. After converting this to 0, then you move on to here. This you make it into 1, and then this to 0. If we go by this pattern, then we get the answers easily. So let us write this matrix as A equal to I into A. Then this will be 2 minus 3, 3, 2, 2, 3, 3 minus 2, 2. Minus 2, 3 into 1, 0, 0, 0, 1, 0, 0, 0, 1 into E. So our aim is first to convert this to 1. So that is R1 will be written as R1 divided by 2. It will convert this to 1. Then after we have to convert this to equal to 0. So it will be 1 minus 3 by 2, 3 by 2. Second and third row will not be changed. 1 by 2, 0, 0, 0, 1, 0, 0, 0, 1 into A, and then 2, 2, 3, 3 minus 2, 2. Okay. Next our aim is to convert this to equal to 0. How to? 2 belongs to R2, then R2 should not multiply with any number here. It should be alone, R2. Then minus, we need 2. 2 with R1. We have to use this element 1 to make these two zeros. That is important. So R2 minus 2, R1. Then how we convert this 3 to 0? So R3 belongs to R3. So R3 minus 3, R1. If you apply this operation in all the elements of R2 and all the elements of R3, automatically it will be changed to 0. Then we go here, we make this to 1, and then similarly divide by the number which will come here, and that by throughout this row, and then it will convert into 1. Then you make these two elements to 0, and then come here and make this to 1, and then convert these two elements to 0. Then you will get the inverse of matrix. Then what about you do the remaining? I will leave it to you. Then column transformation. column transformation is, as I told you already, in row transformation you have to use only the row operations. In column transformation you must use only the column operations. So if it is a 2 by 2 matrix, 1 minus 1 2 3, we convert this to 1 first. Let me take another number 2. Change this to 1 and then go here and make this to 0 and this to 1, then you convert this to 0. So in column transformation we go in this pattern. Then we get the answer. Then 3 by 3 matrix, 2 minus 1 3 0 5 6 4 minus 4 2. Here also we start with this element, but we go here. We convert this to 0, this to 0, this to 1, and then you come here and then convert this to 1 and make this to 0, 0 0, and then you go here, make this 1 and then convert this to 0, this to 0. Here it ends. Okay. So if you practice all the problems in your exercise, then you will learn this method very easily. It's interesting if you have patience and if you do the operations carefully, plus minus, addition subtraction only mostly it involves, and simple fractions it comes. So if you practice thoroughly, then it will be easy for you all. We will see in the next session, we will start with the next chapter, determinants. See you in the next session. And if you have any doubts or any queries, you can contact me to this mail ID, tpungudi90@gmail.com. I can help you out. Thank you.